we will quickly revise the last point what we studied. The last point that we studied was plate height, number of plates. Both these concepts were part of uh, a theory called as plate theory. Okay, plate theory is designed to describe efficiency of column quantitatively. That means in terms of numbers. So obviously we are going to encounter some equations. The first equation we encountered was relationship between number of theoretical plates and uh, height of those theoretical plates. It was n is equal to capital L divided by h, where L is the length usually counted in centimeters of the column packing, n was the number of theoretical plate, and h was the height of that theoretical plate. Now, I specified that many times in previous lecture. I am repeating today also that these plates are only theoretical. They do not exist as such. Okay, the stationary phase is uniform. Stationary phase is uniform, and there are no separation or gap between different layers of stationary phase. In fact, there are no layers as such. It is uniform completely. Now, this particular theory, moving on, was put forward by two scientists, Martin and Sinch. They treated that chromatographic column as if it is was a distillation column. जो आप केमिस्ट्री के लैब में लगाते हो रिएक्शन के लिए, द डिस्टिलेशन कॉलम. They treated chromatographic column as distillation column made up of numerous discrete but continuous narrow layers called theoretical plate. So when in exam they ask definition of theoretical plates, you will write this particular terminology. See, it is very difficult to scientifically tell the definition of theoretical plate. So you can use the analogy of the column to the distillation column. And as Martin and Sinch, the pioneer of the theory, what they described as theoretical plate, even you can use the similar terminology in exam when it is asked. Now, to elaborate this term, they further stated that at each plate, equilibration of solute between the mobile phase and stationary phase was assumed to take place. What they assume under this theory, that at every plate, the solute equilibrates between mobile phase and stationary phase. Okay. Now, movement of the solute down the column was then treated as a stepwise transfer of equilibrated mobile phase from one plate to the next plate. In previous lecture, we studied this elaborately. There was one student asking, सर फिर इसमें तो जोन ब्रॉडनिंग तो नहीं एक्सप्लेन हो रहा है, बैंड ब्रॉडनिंग तो नहीं एक्सप्लेन हो रहा है. I told that student that we will see further how it is related, correlated. So this last point on this slide is related to that. The theory was ultimately abandoned in favor of the rate theory. मतलब जो हमने random walk theory देखा था इसके पहले. Okay, so this plate theory was abandoned and rate theory was accepted because the plate theory fails to account for peak broadening in a mechanistic way. Mechanically, it could not explain why the peaks are getting broadened. Now, let us further go deep into this plate theory, because rate theory generally will not give you numbers, okay, related to efficiency of the column. But the plate theory is still used to define how column is efficient or how it is not efficient. As you remember, you must be remembering that all the signals that we get in chromatogram after the elute containing your sample that comes in detector will detect the signal and you will get the signal in the form of peak. Those peak are in the form of a Gaussian curve. Okay, it is in the form of Gaussian curve. when we studied Gaussian curve in previous semester under statistics, अच्छा पहले do you remember what is Gaussian curve? Do you remember Gaussian curve? How we used concept of Gaussian curve in defining certain statistical term, confidence limit. We used Gaussian curve when we studied confidence limit of any determination. So suppose I have conducted one experiment. In that experiment, I I have taken thousands of reading. Suppose I have taken 1,000 reading. Okay, I have taken 1,000 reading. Suppose that experiment is a of determination of thickness of the tablet, और मैंने 1,000 tablet का thickness measure किया. Okay, if this is the experiment, for that 1,000 measurements, I can take the mean. Okay, I will take for those 1,000 measurements, I will take mean of the thickness. Suppose I got mean thickness as 0.5 centimeter. Okay, I got mean thickness as 0.5 centimeter, and the variance, the standard deviation. First, I will talk about standard deviation. Suppose standard deviation, I must write units. Okay, standard deviation was 0.01 centimeter. Then what will be my variance? It is 0.0001 centimeter square. So that will be variance. It is sigma square is variance. Okay. So for that particular determination, this is the mean value. So x bar is 0.5 centimeter. Now, if I add 0.5 centimeter plus the standard deviation, I will reach over here. So it will be 0.51 centimeter. And if I minus the standard deviation from the mean value, I will reach to this point. It will be 0.49 centimeter. Now, let me change the ink so it will be a little easy for you to understand. If I consider this area, which I am highlighting right now with light blue color, if I consider this area, which comes under the range of x minus sigma to x plus sigma. Okay. Okay. This particular area will represent 680 tablets out of 1,000 tablets. In other words, it will represent 68% of the tablets. In other words, for these 680 tablets, the thickness of the tablet will be between 0.49 centimeter to 0.51 centimeter. So 680 tablets with thickness between 0.49 to 0.51. Okay, there is one more characteristic which I need to remind you before we proceed further. Okay, now there is another area. Okay, consider this point, huh? Consider this height. It is x plus 2 sigma. 2 sigma मतलब यहाँ पे क्या होगा? X plus 0.02. मतलब it will be 5 point. मैं यहाँ पे लिखता हूँ. There is no space otherwise. Okay, the area is the 5.02 centimeter. 5.02 centimeter, and it is 0.48 centimeter. Okay, so now I will change the color of the brush, and now I will color larger area. I hope this color is visible to you. This large area of the Gaussian curve between x plus 2 sigma and x minus 2 sigma, that is between 0.48 to 0.2. I shouldn't have write 0.48. It is.
Sir, it is
I'm very
0.48, but
sorry.
यहाँ पे 0.5
हाँ हाँ हाँ
आएगा.
हाँ 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 0.5 आएगा. I'm sorry. It is my mistake. Okay,
5.2.
0.52 आएगा. Yes, yes, yes. Okay, my mistake. Okay, 0.52, 0.48 से लेके 0.52 तक, whatever the area of the curve is, area under the curve is, this large area will represent 960 tablets. In different terms, I can say that 960 tablets out of those 1000 tablets will have thickness between 0.48 centimeter to 0.52 centimeter. Okay. I hope this concept you have recollected. We are going to apply this this logic, this concept when we are going to discuss thickness of the thickness or height of the theoretical plate. Okay, we are going to apply the same concept over here. Now consider that I have injected my column with 1000 microgram of the drug. 1000 microgram मतलब कितना हो गया? 1 milligram. लेकिन to understand in a easy terms, let us consider that I am injecting column with 1000 microgram of the drug. Now, okay, when I am injecting with 1000 microgram, अभी यहाँ पे 0.5 सेंटीमीटर मीन है. Consider it that consider this as the mean time for the signal is say 0.5. अब ये 0.5 नहीं, हमको इधर 5 कंसिडर करना पड़ेगा. इट इज सपोज 5 minutes. ओके, दिस इज 5 minutes. Okay, so after 5 minutes you are getting the peak. You are getting the peak. Accordingly, changes I will have to make. Second. So sigma will be 0 minute. It will be 0.1 minute. If that is 0.1 minute, sigma square will be Any guesses? What will be sigma square? It will be 0.1 minute square. Okay. So after 5 minutes, you are getting the peak. So sigma plus 1, sigma, x bar plus sigma will become 5.1, and mean minus sigma will become 4.9. X bar plus 2 sigma will become 5.2 minutes, and this will become 4.8 minutes. Meaning, out of 1000 microgram, 680 microgram of the drug will be eluted between 4.9 minutes to 5.1 minute, and 960 milligram microgram of the drug will be eluted between 4.8 minutes to 5.9 minutes. Do you understand how I correlated the logic of sigma curve of errors to this signal produced by column? Can you correlate? I will repeat my statement. Okay, if the mean time, that is the peak, is obtained for that particular drug at 5 minutes, that means between 4.9 minutes and 5.1 minutes, 680 microgram of the drug is eluted, and between x minus 2 sigma, that is 4.8 minutes, to x plus 2 sigma, 5.2 minutes, 960 microgram of the drug is eluted. Okay, now coming back to the definition of the plate height and plate theory. Okay, the breadth of the Gaussian curve. Okay, मतलब वो Gaussian curve कितना you can say broad है. That breadth is described by the standard deviation or its variance. We have seen that in statistics. Sigma is important when we talk about Gaussian curve. It is described by the sigma. Okay, so this Gaussian curve is your peak, shape of your peak in chromatography. Okay, so if that is the peak in chromatography, the plate height h is given by the formula h is equal to sigma square divided by L, where L, what do you think? What will be the L? What will be L here? Okay. Someone is saying mean. Okay, ठीक है. Let us see what is L here. Don't worry, we will catch it. Okay, L carries the units of centimeters. Okay, L is the unit of centimeters, and sigma square is we are measuring in centimeter squares. Okay, so h represents linear distance in centimeter. So h represents linear distance in centimeters. So h here is plate height. Okay, let us continue. The plate height can be thought of as, can be defined as the length of column that contains a fraction of analyte that lies between L minus sigma and L. I will repeat this. Okay, the plate height can be thought of as the length of column that lies between L. Try to correlate. Okay, share this tab. Okay, so we are talking about this distance. Okay, this was your mean, x bar was your mean. So x bar minus sigma, इसमें जितने मॉलिक्यूल्स है, अपना थेरोटिकली कितना ग्राम का ड्रग होना चाहिए फिर अभी यहाँ पे 340 microgram drug. So that length of the column, that height of the column, which contain 340 microgram of your drug, that height will be called as plate height. Is this definition clear now? जिसको जब when I applied the sample from the top, okay, all 1000 molecules I have applied from the top, and then I added mobile phase. Those 1000 micrograms, why I'm saying molecules, those 1000 micrograms will start traveling down the column. Now when they are down the column, okay, plate theory assumes that the bandwidth will remain same. Width of the band will remain the same. Okay, considering that as the compound is traveling down, the height of the molecule, height of the column, which will contain 340 microgram of the total 1000 molecules, will be defined as plate height of that column. I will try to elaborate it more. Suppose this is your column. Through the column, your sample is being your sample is being traveled. Okay. Now plate theory क्या assume करता है कि वो uniformly हो रहा है depending on the plates. Okay, it is not considering the broadening. Anyway, so this entire height of the column, entire length of the column which contains the drug, it will contain 1000 microgram of the drug. यहां तक समझ में आया? The entire area in which the drug, that molecule is spread, it is that total molecule is 1000 microgram. Only part of, considering that the drug is distributed evenly, there will be a small part of the column which contains 340 माइक्रोग्राम. अब ये 340 कहां से आया? ये आपका जो मीन था एक्स बार माइनस सिग्मा, that is your standard deviation, E is equal to 340. In this particular case, I am giving you example and explaining. Okay, so this is x minus sigma. तो इतना क्वांटिटी ऑफ ड्रग जिस हाइट में, जो पार्ट में है कॉलम का, that part is your plate height. That height is your plate height h. Have you understood it now? Okay, I will read the definition again. I hope that it will make sense now. The plate height can be defined as the length of column that contains a fraction of analyte that lies between L minus sigma and L, where L is the length at which you are getting the peak. Okay, where L is the length at which you are getting the peak. You are measuring the analyte at length L. Because the area under the normal error curve, your sigma curve, Gaussian curve, bounded by sigma, is about 68% of the total area. मतलब ये जो एरिया है L minus sigma and L plus sigma, it will cover the 68% of the curve. Okay, 68% of the total area. The plate height as defined contains approximately 34% of the analyte. So that height of the column that contains 34% of the analyte is your plate height. You understood it now, students? Is this entire slide understood, well understood? Then I will proceed. Okay, saying that they have understood. Okay, now I want you people to draw this diagram. I am going to enlarge it. Please bear with me. In your book give heading as definition of the plate height. Under that, draw this diagram. जो ऊपर का diagram है वो draw करो. Suppose this is the column. See this part of the diagram. This is your column, and at this point you have the detector. At this point you have the detector. From here the sample is injected. Sample is traveling from here through the column packing, and it is getting detected at this point. Okay, so it will get detected at this point. The compound, when it is detected by the detector, see, you are going to plot this particular curve when the entire compound is getting over. Okay, but when compound is eluting from the column, okay, you will get a graph like this. When you have reached to the peak, okay, when you are reached to the peak, you are considering that particular point, that particular time as the peak time for your analyte. Okay, at the peak time for your analyte. So when you are getting that peak time, you are considering the entire length of the column. So in this particular formula, this capital L is the same capital L you have used previously in previous equations of this chapter जो हमने लिखे थे. So it is the length of the column itself. It's going to change for different analyte. Sigma is going to be changed. Okay, I hope you understood this concept. Now, next concept is experimental evaluation of H and N. Experimentally, हमको height of the plate and how many number of plates present in that particular column is present. Can we calculate that? So yes, for any column, the plate count capital N and plate height capital H are widely used in the literature and by instrument manufacturers as measure of column performance. Although the plate theory has been abandoned, all the manufacturers will give the H and N as their specification. जैसे आपका मोबाइल का स्पेसिफिकेशन रहता है 2 GB रैम 32 GB मेमोरी like that. These H and N are specification from instrument manufacturers. Now, capital H, that is plate height, can be calculated from experimental chromatogram. Now, I want you people to observe this chromatogram. Let me magnify this. Okay. Have you seen this diagram before? Have you seen this diagram before? हमने ऐसा diagram देखा है जब हमने retention time का definition देखा था तब हमने ये देखा है. So even here you can see TR and TM. You can see TR and TM. Coming back to this diagram, I don't know if I can zoom it or not. No, I cannot zoom it. I'm sorry. Zoom out हो गया वो तो. Okay. अरे हाँ है इधर zoom का function है. Okay, I found it. Very good. Okay, if you observe this diagram, the pink part of the area, okay, this part of the area between x minus 2 sigma to x plus 2 sigma, it is representing 96% of all the analyte that is being injected. So we can consider this particular area as approximate triangle. Okay, and we assume that most of the analyte is present in this triangle also. We, for simplicity, I'm repeating, for simplicity, we will neglect 4% of the analyte. Okay, we will neglect 4% of the analyte so that we can use this triangular shape for our calculations. Now, let us come back to the slide. Okay, So can you see the approximate triangle drawn over here? So there is approximate triangle drawn, and the lower part of the triangle is considered as the width of the peak. A small thing you need to consider. See, this small triangular part from the Gaussian peaks are eliminated, but this small triangular peak is included over here. So it is some compensation to that 4% that is eliminated. Acha, but no book is discussing this, but this you can consider for your understanding. Okay. So this is the width of the peak at its base. What W is? I repeat, it is the width of the peak at its base. Have you understood what W is? I repeat, it is the width of the peak at the base of that peak. Okay, now if you have understood that, I hope the further discussion will be easier for you to understand. Okay, I will read out some part from the slide. At the inflection points on the two sides of the chromatographic peak are extended to form triangle. Triangle matlab, see, we are talking about this ascending part of the curve and descending part of the curve. So we are going to draw tangents on that part. So those tangents will form a triangular with this baseline. Okay, the first sentence, I hope it is clear to you. So this is the triangle we are talking about. Okay, the area of this triangle can be shown to be approximately 96% of the total area of the peak, as it is Gaussian peak. We just saw the explanation. Now, अभी ये स्कूब में से है अपेंडिक्स 1B1, उसमें से अपेंडिक्स 1। अभी ये क्या बताया गया, हमने जो स्टैटिस्टिक्स पढ़ा था पिछले सेमेस्टर में, वो उस चीज का अपेंडिक्स है। ओके, so that statistics shows that 90% of the area under a peak, area under a Gaussian peak, is included within plus and minus 2 standard deviation, plus minus 2 sigma of this maximum. Thus, intercept as shown in figure below occur at approximately plus or minus 2 standard deviation of the solute peak plus minus 2 tau. This tau is considered to be as the sigma for for this particular p. Deviation is represented by tau. हमने tau क्या है वो देखा था last time. Okay, 2 standard deviation from solute peak plus minus 2 tau from the maximum, and W is equal to 4 tau. W is equal to 4 tau, where W is magnitude of the base of the triangle or the width of the base of that particular triangle. Substituting this relationship into previous equation. Which equation I'm talking about? I'm talking about this equation. Okay, so it will become LW divided by 4TR. Okay, TR is retention time. So H will become LW square divided by 16 TR square. Okay, now we know that N is equal to LH. So N becomes number of theoretical plates becomes 16 into TR upon W square. Now, please in your notebook give heading as experimental evaluation of H and N. In that, draw the diagram and take down these three equations. Let me know when you have copied diagram and equation. Oh, it is 3:24 already. Meenal Aradhana, it is okay. I don't want next lecture to get delayed. We could not cover the part which I wish to cover in this lecture. So